Okay, we have a differential equation, and we're trying to find the slope field that matches. Lots of ways to do it. I'm going to start with quadrant 1, actually. So any x and y that I pick in quadrant 1, your dy dx, based on this equation, should be a positive number. But notice answer choice A has some slopes that are negative, so it can't be A, and it can't be D. Let's see if there's any other. I know that in quadrant 3, you're based on the equation, your dy dx, so if you pick a number here, your x is negative, your y is negative. This should also be positive. But if I look at my two answer choices left, it doesn't look like that helps me, okay? But you can keep going. Let's try quadrant 4. If I pick a point in quadrant 4, your x is positive, y is negative, so that means your slope should always be negative. But it doesn't look like that helps me. Okay, so I kind of checked through my quadrants, and I'm still down to answer choice B and C. Now you can start looking at some individual points, things like that. One thing I do notice on answer choice C is notice that it looks like these slopes, so it looks like on the 45-degree diagonal, they are the same. So when x equals 1, y equals 1, my differential equation tells me, based on this, that your slope is 1. And it's positive. I'm not sure if it's actually 1, but we can leave it for now. But notice, if I do x equals 2, y equals 2, my dy dx should be 4. It should be a much steeper slope than what I have in the slope field, but based on the graph, it looks like it's the same value. So that's why I'm going to rule out this, and I'm left with B as my answer choice. Okay, the next one here, we are solving a differential equation. And remember, to solve a differential equation, we have to separate our variables. So that means get the dy's and the y's together, get the x's and the dx's together. So there's step 1. Let's go ahead and integrate both sides. So on this side, I get natural log of y. On this side, it's 4x squared divided by 2, which is 2x squared plus c. Remember, I only need to put the plus c on one side, because if you put plus c on both sides, you can move them over and it's still a number. Okay, we're going to rewrite this as an exponential. So e to the 2x squared plus c, make sure all of this becomes your exponent is equal to y. And if you remember, using properties of exponents, this e to the c is just really another number. So we want to be able to simplify it to this. Okay, so if you want to go straight from here to here, that would be fine. Now I have a point to plug in. They tell me when x is 2, so if I plug in 2 here, I get 8. Y is equal to 1, so let's go ahead and solve for c. So c is really 1 over e to the 8th, or that's the same as e to the negative 8. So my final solution is y equals e to the negative 8, e to the 2x squared. I don't see an equation in that form, but notice answer choice A, they went ahead and used the properties of exponents to rewrite it with one base. So your answer is A. Okay, and the last one, 128, is same idea. We are going to solve this. Anytime they ask you to solve it, we have to separate our variables. So the only ways you can get the p's with the dp's is to divide all of that p minus 3, okay? And then we have dt here. Let's integrate both sides. So I have natural log of p minus 3 equals t plus c. Rewrite it as an exponent. E to the t plus c equals p minus 3. And then using the same idea that we used in the problem above, this really simplifies to this. And then I'm going to move the 3 here. So this is my solution. They tell me when I plug in 4 for t, I should get out 2 for p. I'm using this point. Let's go ahead and solve for c now. There's that. So c is really negative 1 over e to the 4, which is really the same as negative e to the negative 4 if I bring that exponent to the top. So now if I plug it in here, so p is really negative e to the negative 4 times e to the t plus 3. So I'm looking for this solution, but remember multiple choice, everything's always simplified. So notice this piece, they have combined it using properties of exponents. So your answer choice is C.